Hi, everybody. This is Zhengyi. I'm from Soning R&D Center at Palo Alto. It's my great pleasure to introduce our project to each of you here. So I'm the Deputy Director of Big Data Lab, and what is Suning? Suning is China's largest retail store. We have like 1,600 brick stores in China. More recently, we get government license for bank services. So you will know why we are doing the big data, the modeling, and all the services, and we practicing it with Apache Spark. So most of people here are either software engineer or data scientists, or both. So software engineer want the data model from the data scientist. They want provide or host the model and the service to their products. But what is data scientist want? This is maybe the top 3 wish list from a data scientist. Top 1, we want data, a lot of data. They must be clean and to be better. They had better to be labeled. So about the data thing, it is a chronic pain. The jokes about the messy data, like last year, a person called Jennifer Null, N-U-L-L, had a problem registered with the IRS website because he always bad respond from that website says your last name cannot be registered as Null. Yeah, and there are other things about the messy data, like we have like 3,100 users. We have like 300 millions of users. So we have a lot of users. Their first name is custom. Their last name is Mer, so they're Mr. or Miss Customer. So the second thing on their wish list might be they want powerful computing. They want a lot of Spark nodes to make their computing lightning fast. The third thing is data scientists want an easy-to-use tool to apply their statistical or machine learning models. So they want no hard grammars, no long or hidden parameters so that they have to spend an entire afternoon to debugging to find out the parameters, hidden things inside of it. So here is what we do for you. We developed this Spark backend Codeless drag and play Teams workspace machine learning service. This is the project my team and headquarters team developed for 1 year. Headquarters is doing the front end and the service. Our team is doing the algorithms on top of Spark. So this is a simplified gift card fraud detection demo. So you will see it have 3 sections. The left is the operators. The middle is the process. The right is the parameters. So you choose one operators, like an algorithm for the processing, drag it to the canvas. Like the first one is the Hive table. You load the data with the Hive table on the right parameter. The table name will automatically jump out because our solution is an integrated solution. It's connected with our data warehouse. So then we need to split the data into training and testing. So we drag the second node from the left and drop it onto the canvas and use a line to connect them to say, oh, this is the workflow. So every node, you can right-click it to run it. And you normalize the data and training here is just a simple example, logistical regression. And then, because we do the normalization, so we have to apply these transformation rules on the reserved testing data set. So you see the second line from the split data, that's the reserved testing data into the apply transformation, and then going to the model and feed the testing data into your trained model. And we have that evaluation node. If you right-click it, there's a lot of more functions. You will see the evaluation graphs and the data show how your model performs. So this is the brief introduction how to use this platform. However, this is not easy to make your work easy. Spark machine learning library has growing very fast. In the past 1 year, around we started, it's almost doubled. So this is the entire list of the machine learning library, DataFrame-based API. There's a lot of some RDD-based API. Some algorithm didn't convert it to here. But you will see there are feature transformations, extractors, classifications, regression, a lot of the things. So our work is to retesting it and wrap it and try our best to visualize it, to make every item a node in our canvas. That's what we did. However, that is not enough. Here is the reason why we extend it. Because as you remember, I mentioned that we have the bank service, but our research go earlier. Like 2 years ago, we are doing the credit model. We have to give credit scores to like 300 million of people. That doesn't work for R or SAS. It's too expensive. So we try Spark for good sake. It solve our problem. So, but during that practice, building our credit model, we found same functions repeatedly written by different engineers. So the first reason is, why not we generalize it to make it, to make other people can use it? The second reason we are using it, because we find our data scientist, software engineer always looking for new algorithms. They go to Google it, find open source, and test it along. So why not integrate them to have some people to do it for them? So this is the two main reasons why we generalized it and made the extensions. So we did, in the past year, we did 3 major extensions. First is the data processing. Second is the time series analytics algorithms and modelings. The third is the domain-specific library for financial services. So here is the list of our new add-ons. So we have added a lot of sampling, statistic, testing method, graphics, feature selection, transformation, operations, classifiers, binding method, time series, and natural language processing. So let me explain, selectively explain some of it to you. For example, sampling. Remember in Spark 2017 East, a lot of people believe that big data plus big model equals more accuracy. If so, but in real practice, things is not like that. No engineer will, at the beginning, apply big data to model, waiting like 2 days, half a day to get the model. People always sample it, get a small data set, and test around building this model. It works good, or maybe runnable from the beginning to the end. So sampling is a very useful and popular, repeatedly used tools. So we add sampling method. We add some weighted sampling, cluster sampling, random sampling, and a more sophisticated one, smooth sampling. I will introduce smooth sampling later. So for another example, if for some data scientists, they're very familiar or quite comfortable with R, so that they use a lot of traditional things, they're still very usable, like weight of evidence, information value, but the Spark environment do not have it. So we also implemented in Scala to make it a native extension. And we also incorporated the most popular XGBoost in the Kaggle competitions into our entire list. So in this way, our platform is more usable and have a richer pipeline for data scientists to choose. And they do not need to repeatedly to looking for new things and incorporate or try them separately. The second extension is our 10 series modeling algorithms. So let me explain the data set we use. We are using the US economics data. You will see at the, did you see here? At the top part is our platform can visualize the data in a very nice way. The first is the date. The second is personal consumption expenditure. The third one is the population in thousands of people. The fourth one is the personal saving rate. And the fourth one, this one is the unemployment in weeks. The last one is the unemployment people in thousands. So here we see in 2006, the data is not good. People spend more than saving. So for the time series one, the most popular one is the Sandy from Cloudera. They have the most popular open source one. I'm saying the open source one. Time series is from the Sandy at Cloudera. He considered the 3 implementations. 2 are DataFrame based, 1 is RDD based. He says DataFrame based is ideal, but he decided to choose RDD based because RDD is they decided to focus on the performance faster. So the data is like this. So, but the problem is, his method is faster, but they use time series special RDD format to store the data called RDDK. It extends RDDK vector. The vector is Breeze vector, so it's not distributed. So if you are a believer of big model and you have a huge lines of series, then your data cannot be loaded and cannot be computed. Your thing will stop. I will give you the comparison in a later slides. So, but we re-implemented everything, all the algorithms he had, but in a data frame-based structure. So the good news is you have more semantic support, and you have better optimization, but in some other ways, in some bigger data ways. So that's we have. So here is the list we implemented. So we have the data frame thing. If you are a R user, you are more happier using ours because our thing is more natural. Use the data frame, and you can use classic machine learning method with supervised learning to compare. If time series analysis is optional, you also can use XGBoost or to compare. Actually, we did both to compare. We have the new thing about they do not have its time series decomposition. So this is our platform visualization. It's pretty good. So you can see the 60 years US economics in one picture. The first is the original data. The second is the noise. The third one is the seasonal. The fourth one is the trend. So also we implemented 2 methods for the ARMA ARIMA. So at least data scientists have choices, because in some people says, oh, your worker has better results, have more accuracy, but just in some case. But with our tools, you at least have options to choose which implementation for the ARMA is better. for that data set. So this is our platform works. You can drag the data into the top, load the data. You can deploy it to see the data plotting, and you can drag the ACF, PSF to determine the parameter for AIMA. And if you are lazy, just drag the auto-arima. It will tune the parameters for you. It will choose the model for you. Then here, you get the model, and you drag another node for the new data and apply that model to your new data and get the evaluation thing. So here is the comparison of our experiment. Maybe I shouldn't put R here because it's a single node version we are using. But for this two, we just using 8 GB memories and 5 cores. We're just doing small testing. So as we can see, because Spark TS is using the dense vector-based, so it's pretty fast, but it cannot handle larger data if the sequence of that array is too huge. But we sacrifice the performance introducing operation cost, but at least you can get some results if you are a big model believer, because big model believer may enable you new discoveries. Our third addition is our domain-specific library. It's for the financial services. Our first example is about the fraud detection for gift cards. This is for the account takeover detection. So for the account takeover detection, the problem is pretty classic. It's the class imbalance problem. So in order to address this problem, we have 3 methods: sampling, weight assignment, and anomaly detection. For the sampling problem, we can do the simple thing like down sample, up sample, or the combination. But this simply down sample or up sample may cause overfitting problem. So a more sophisticated way is to use smooth sampling. Just the smooth function just generate some synthetic positive labeled data injected into the original data for you to train your model. So for the weight assignment, we implemented some cost-sensitive learning method to adjust the weight of the node. Here, we implemented the cost-sensitive decision trees to change the weight of the nodes and generate some prediction. Because of the problem of the use case, the positive samples are extremely small. So we have to do some unsupervised learning to use label propagation or other method or label functions to make the labels a little bit expelled to give risk scores to its neighbors. So we use IP mapping, mobile number grouping, bank card decoding, national ID decoding, and we add some GraphX algorithms like K-call modularity to detect the community, the call number of calls. And we also conducted some research on hypergraph algorithms to detect the malicious users. Why we are using hypergraphs? Because you cannot believe, how many people share their bank cards and how many people share their mobile phone numbers. Here, you carry your mobile phone number from here to another carrier, but don't forgetting those using prepaid phones. And in China, we have the virtual carriers, so the phone numbers are pretty easy to change. So mobile phone number grouping is a big issue and a topic for us. So we are using these things to detect the account takeover. Thank you so much. So we have our online demo at YouTube. You can click that thing later, see our YouTube demo. Yeah.
Okay, thank you. Appreciation. Any questions for Zhengyi? Okay, one question.
Have you are any of these algorithms that are not proprietary to your application, have you committed them back to the Spark libraries? Like the smooth sampling and the other sampling stuff, it's not really proprietary to your company, right? So are you giving it back to the open source community?
Some of the algorithms that you were describing, Zhengyi, have you committed them back to Spark?
Yes, that's what we are trying to do. But new functions is got lower attention than bug fixing. So they have over 500 or 400 pull requests. Okay. Yes, some of them are on the line of pull requests.
Okay.
Thank you. Any more questions? Okay.
One question. So when you compile the pipeline, just all the DAGs into some jobs, and do you use a Spark ML pipeline API, or you have your own DAG execution?
We all use Spark.
So going back to that DAG, you said that the user can right-click and run that stage. So is each stage considered a Spark, an independent Spark job, or are different stages combined together to form one huge Spark job? How does that work?
Yeah, 1 second, please. Multiples.
Multiple jobs?
Yeah.
So that means each stage is
Yeah, we
its
have
own.
a workspace, yes.
Okay, so, and then like the results of that, would that be saved somewhere, and then the next stage would pick up the results of the previous stage, or how?
Yeah, we put it back to Hive, so that's quite slower. You mean the nodes between nodes?
Yes.
Yes, we put it back into Hive. We store it. You can start later.
Okay, and there's any plans on open sourcing that DAG scheduler?
What?
The DAG scheduler, will you open source it?
I talked it with the headquarter team. They're deciding it.
All right, okay. Thanks.